Alright, my little math friends, we are moving on into Chapter 7, and Chapter 7 is about these things called Algebra Inequalities, and we're going to solve them. Okay, now that may sound a little scary at first, but let's talk about what an algebra inequality is. It is an algebra equation where the two sides are not equal to each other. Okay, and let me tell you why. Here we have an algebra equation like we dealt with in Chapter 6 where we have x plus 5 equals 12. Okay, this side over here is equal to this side over here because we have an equal sign. Alright, an inequality is just like what it means. It is unequal. It is not equal to each other. So we have these four symbols that we deal with. We have less than, greater than, less than or equal to, greater than or equal to. Okay, that's what an algebra inequality is, and when we go about solving them, I have some good news for you guys. Okay, some good news, a positive, that we solved them the exact same way that we did in Chapter 6. Okay, isn't that great? We're going to use the same exact steps. Alright, so let's take a look at this and see exactly how we go about doing this. Alright, so here's a couple of examples. Let's say we have x plus 5 is less than 12. We're going to solve it the same exact way we did in Chapter 6. We want to cancel off the number over here with the variable. So I'm going to do the opposite. I'm doing minus 5, draw my line. I have x, and then I'm bringing down my less than sign, and 7. 12 minus 5 gives us 7. Okay, that's our answer. And then what we also do with inequalities is we like to graph them because we don't know exactly what number x is. We know that x is less than 7, but we don't know exactly what it is. It's some number that is less than 7. So here's how you graph it, okay? Since x is less than 7, it can't be equal to 7. So what you do is draw a circle around 7, and that circle is going to be like a fence. Okay, you're blocking out 7 because x cannot be 7, and then we're going to draw an arrow for all the numbers less than 7. So what that is showing is that x can be any of these numbers here, less than 7, but it cannot be 7. We put that barrier, that fence around it. Okay, that's how we graph it. Let's check out if we're going to graph this equation over here. It's the same thing we just did. Okay, we're canceling off the 5. Alright, so we have x is greater than or equal to 7. Okay, same answer, just our inequality sign changed a little bit. And we're gonna, when we graph this one, since x is greater than or equal to 7, since it can equal 7, you're going to put a filled in solid circle on 7 because it could be 7, but we don't know. And it could be any number greater than 7. So I'm going to put an arrow to show it could be any of these numbers over here greater than 7. Alright? Simple enough. Let's try a few more examples and see what we got. It's the same exact steps from Chapter 6. We're just going to deal with inequality signs and graphing them. Okay? So here we have 6 is less than or equal to y minus 3. Okay? Same thing as Chapter 6. We need to get rid of this minus 3, so I'm going to make it plus 3 over here. So now I have 9 is less than or equal to y. Alright? Now when we graph this, you can use your little alligator teeth from like 3rd grade if you want to. Alright? The alligator always goes after the bigger number, so y is bigger than or equal to 9. So I'm going to show that on the graph so that since y can be 9, I'm going to fill in 9 all the way, and then I'm going to show all the numbers bigger than 9 to show that it could be any of these numbers up here. So we just draw an arrow that way to show it could be those numbers. Alright? Let's take a look at this inequality here. We have negative 21 is greater than 12 plus x. So we're going to solve it the same way as Chapter 6. We're going to cancel off this positive 12 by going minus 12. Put a minus 12 over here. Do the math on this here. We got negative numbers. We're dealing with subtraction. We're going to do same, change, change. Keep this number the same. Change that, change that. So now we are left with negative 33 over here. We have this symbol and x. Okay, we just dropped down exactly what that symbol is. So negative 33 is greater than x. Alright, so we got our little alligator teeth here. So x is going to be smaller than negative 33. So since it can't equal negative 33, I'm going to put an open circle at approximately negative 33. And then I'm going to draw an arrow all the way over here to show all the numbers less than negative 3. Alright, there you go with your adding and subtracting of inequalities. Let's take a look at multiplying and dividing inequalities, because we have one little step to add into it. Okay, one little extra rule with multiplying and dividing inequalities, and that has to do with negative numbers. When we divide or multiply by a negative number, we are going to flip the inequality symbol. So we're going to do a little flipperoo when we have a negative number, okay? Flipperoo. Do you guys like that word? Because that's what we're going to do. Alright? So let me show you how this would work out. Here we have y divided by 3 is greater than 5. Okay? So we need to cancel off the 3. Since we're dividing by 3, to cancel it off, we would multiply by 3. That would let me cancel. Okay, and then I have to do the same thing over here. Alright, now since this is not a negative 3, since we're not doing anything with a negative number, then we are not going to do the flip. We're going to save that. Okay, so we have over here, we have y is greater than 15. Alright, same steps as chapter 6. Now we're going to go ahead and graph this. Y is greater than 15, so I need an open circle at 15. Okay, because y cannot be 15. And y is going to be greater than 15, so I'm going to highlight all these numbers over here on this side. Alright? Now let's check out when we have a negative number, what happens here. Okay, so same step. This is y divided by negative 3. We need to cancel it off by multiplying by negative 3. Cancel. Now I'm going to bring my negative 3 over here and do the same exact thing, except this time, since you brought a negative 3 over here to this side, this symbol is going to do a flipperoo. Alright, there is our flipperoo. It's just going to flip to the other way. And we're just going to continue on just like what we were doing. We have y over here on this side. Our symbol flipped to this way. And we have negative 15 over here. Okay, it's just the same math. We just did a flip. Now we have y is less than negative 15. So I'm going to put my open circle at negative 15 because y cannot be negative 15. Draw a fence around it, and it can be any of these numbers down here that are less than 15. Alright? Let's check out this next example here. We have 4 times x is less than or equal to 52. Okay, there's no negative number here that we're going to work with, so we don't have to worry about a flipperoo. We're just going to divide by 4, doing the opposite to get it to cancel. Divide by 4, and I have x is less than or equal to 13. Alright, now I can graph it. Since x could be equal to 13, then I'm going to draw a filled in circle here at 13. And x is and could be any number less than 13. So I'm going to highlight all of these numbers less than 13. Alright, now check out this example where this time we have a negative 4 to deal with. We're multiplying by negative 4, so I need to cancel it off by dividing by negative 4. I'm going to bring my negative 4 over here, and when you bring your negative 4 over to this other side, when you bring a negative number over there, then you're going to flip the sign around. Okay, so just flip it and make it go the other way. Continue with your math. X is greater than or equal to negative 4. Or, I'm sorry, negative 13. Because we had to divide that. Perfect. Negative 13. Alright, so now we can graph this. X can be equal to negative 13 or greater than negative 13. So I'm going to put a filled in circle at negative 13 because it could be that. And then I'm going to highlight all the numbers that are bigger than negative 13 because those could be possible answers.